when working with Kotlin, we've already seen many instances where objects had functions which they couldn't possibly have. Like, for example, here a character has a function called down2, and you can actually do z.down2, and you can see other functions in here. So the question is, where did these functions come from? And the answer is that they all come from this idea of extension functions. So let's give a simple example of an extension function. Let's suppose that I have a list, so let's have my list equals array list of 1, 2, and 3, and let's suppose that I want to have a function which actually swaps some elements of the array list. Now, I can certainly inherit from an array list, or I can do some special function which simply takes it as a parameter, but let's suppose that I want to write something like mylist.swap 0 and 2, so swap the first and last elements. How would I do it? Well, this is possible in Kotlin exactly thanks to extension functions. So to define an extension function which actually swaps two elements, what you can do is you can define a generic function. So it will be a function with a type parameter t, which actually operates on an array list of t. So the array list here is what's known as a receiver. That's essentially what we're adding the function to. And then we do a dot and specify the actual name of the function. So in this case, we're having a function called swap, which takes two indices. So it takes index 1, which is an int, and it also takes index 2, which is also an int. So these are the indices of the elements that we want to swap. Now the actual process is fairly simple because we make a temporary where we put the first value, so the value at index 1, then the value at index 1 gets assigned the value at index 2, and the value at index 2 gets assigned the temporary value. Gets assigned the temporary value like so. So you can see that we're using this keyword here. Now this, when speaking of extension functions, refers to the receiver. It refers to the array list. So if we were to invoke this function from here, mylist would be exactly what this actually is. So mylist is the receiver, and the receiver is addressed through this keyword. So we swap the 0th and second element. Let's actually print out the entire list to see what we're getting. Print line mylist, and then let's run this. And as you can see, the list got effectively reversed because I swapped the first and last elements. So this is an example of an extension function, and you can also do extension functions on nullable objects. So let's do an example where we have, let's do a print line for an object in a different way. So let's imagine that we want to have a function which takes just about any value. So we're not going to restrict it to a particular type. We're just going to say that it takes any value, but this value can also be nullable, so we'll put a question mark here. So we take any value, which is possibly nullable, and we want to print it, like so. So what we can do here is, first of all, we can check this against null, because the receiver itself is a nullable object, so somebody could pass us null in here. So if this is equal to null, then we can print line object is null, like so. Otherwise, we can print line object is, and then we can just call toString on it. So this dot toString, toString. There we go. Okay, so the way you would use this is as follows. You can run it on virtually any object because it takes an any. So we can, for example, say mylist.print, print like so, and this would work. So you can see that since this takes an any, every single object magically acquired this extension function called print, and we can call it on mylist because it's an object. So let's take a look at what we get. Fairly predictable. We get object is 321, and similarly, if I make something that's null, so for example val as a nullable string which has the value of null, I can do s.print on it too, and this is also safe because you can see that we have a null check here, and all we get is object is null. Okay, so the final thing I want to show is what happens when you add an extension property as opposed to an extension function. So remember, properties are just combinations of getters and setters. So instead of adding something which is called as a function with round brackets at the end, you can add a property instead. So for example, I can add a property called empty to a string, to check whether it's empty or not. Now, instead of a function, this is a property, so it would either be val or var. In this case, I'll have val because it will be a read-only property. Now, it will operate on nullable strings. So here is a string question mark, and the property itself is going to be called empty. And its type is going to be Boolean. All right, now all I have to do here is specify the getter for this property. So I say get equals, and then for a given string, I want to check that it's empty or not. And I'm saying that if this is null, or the string length is equal to 0, then I'm assuming it's empty. Otherwise, it's not empty. And what we can do now, down below, is we can print line whether S is in fact empty. Now, if I run this right now on a null object, then obviously we get a value of true. But we also get the value of true if I put an empty string in here, because remember, we're checking against the length. So I'm getting a true here. But as soon as I add even a single character and I run this, I should get a value of false. And that's exactly what I get. So the moral of the story here is that you can add either extension functions, including extension functions on any, which will affect every single object, or you can add extension properties. There are some nuances with extension properties, particularly with the fact that you cannot give an extension property a default value, because it is unclear where the backing field should actually be stored. But apart from that, you can certainly implement both of these depending on your needs.